Hi everybody, in this video we'll be going through questions 1 through 12 from the August 2019 Geometry Regents exam. All right, so the first 12 questions, or the first 24 really, but the first 12 are in this video, are all multiple choice. They are right or wrong, no partial credit. So for number 1, on the set of axes below, AB is dilated by a scale factor of 5/2, centered at point P. Which statement is always going to be true? So whenever you have a dilation, parallelism is preserved. And if you notice, and you look at the picture here, AB and A prime B prime do look parallel to one another, and that's always going to be true because parallelism is preserved. That's like saying slope is preserved. If you find the slope of each of those segments, they will be equal to each other. So the answer to this question is choice 2. Number 2, the coordinates of the vertices of parallelogram CDEH are the following. What are the coordinates of P? The point of intersection of diagonals CE and DH. So when you're doing this, if you wanted to graph, you have scrap graph paper at the back of your test booklet. But for this one, I'm really just going to use the midpoint formula. So the midpoint formula is add the x's, divide by 2, add the y's, divide by 2. And we're doing midpoint because the diagonals of a parallelogram bisect each other, meaning they are cut in half. So we're going to pick one of the diagonals. We should get the same answer regardless of what diagonal we pick. So let's say I pick CE. I'm going to add the x values, divide by 2. I'm going to add the y values, divide by 2. This is going to give me -6/2, which is -3. This is going to give me 4/2, which is 2. So -3, 2 is our answer for 2. All right, number 3, the coordinates of endpoints QS are -9, 8 and 9, -4. We want to partition this into a 1:2 ratio. This is one that I would choose to do graphically. So again, in the back of your Regents booklet, and you can tear it out on test day, you're going to have scrap graph paper. So I'm going to just scroll to mine here and show you what it looks like. So it's one big page of graph paper, so you'll have to draw it in your own axes. So I'm going to go ahead and do that. So any of these partition questions, as I'm drawing this here, I think are much easier to do graphically. I'm just going to slide this over. And this type of question where you must partition into a particular ratio seems to be something they are putting on the Regents exam every single time and just changing numbers. So this problem gave us -9, 8. And I'm going to plot that here. And 9, -4. So here are my 2 points, and I'm going to make a nice straight line connecting them. So you're obviously going to be doing this on paper, not on the iPad. And basically you are going to use, you could use your safety compass if you use that as a straight edge to connect and make a nice straight line. That's key on this problem, to have a nice straight line in order to calculate our answer graphically. So this problem, if we remember, was looking for a 1:2 ratio. So that means there should be 3 total parts to this line segment. So we know that because 1 + 2 = 3. We want there to be one little segment to the left, and then basically 2 little segments to the right, and all of the segments should be congruent to one another. So what I'm going to do, I'm going to eyeball it first. But I'm going to plot points that I can see that looks like it's going to split this original line segment into 3 congruent parts. If that's hard to do, and sometimes the bigger the line segment, the harder it is to do, what you could do is use the slope of the original segment. So the original segment, I make like a big triangle using the slope. The original slope was that we were going down 12. And we went to the right 18. If I divide those numbers by 3, again by 3 because we need 3 total parts, so that means down 4, divide by 3 over 6. Now look at my starting point up here. Go down 4, go over 6, and there's that first point. Okay, so you can use slope triangles to help you. So anyways, this is our answer right here because there's one little line segment to the left. There's two line segments to the right. So that coordinate looks like it is going to be -3, +4. So let's go back to our questions. And yep, that looks like choice 3 here. All right, number 4, if the altitudes of a triangle meet at the triangle's vertices and the triangle is, this is going to be choice 1, a right triangle. If you have a right triangle, you can see here that the altitude is basically going right through the side. Like that's if I extended it to make a line anyway, the altitude is the side. And if I rotated it, here's another altitude, and they meet right at that right angle there. All right, number 5, in the diagram below of triangle ACD, DB is a median. That means AC is split in half. And we also know that AB is congruent to DB. Okay, so that looks like it's going to be an isosceles triangle here. An isosceles triangle, yes, has 2 congruent sides, but it also has 2 congruent angles. So since they gave us that AB and DB are congruent, I know that angle A and angle BDA must be congruent because it's an isosceles triangle. All right, so we know that angle DAB is 32. That means this up here is 32, right? We just established those are congruent. And we're looking for the measure of angle BDC. So I'm just going to put a question mark in the angle we're looking for. All right, so if we look at this, let's look at triangle ADB. We know every triangle has a sum of 180 degrees. So if I subtract those 32s, that makes this obtuse angle in here 116. These are on a straight line, so this is going to be supplementary, and that becomes 64. And then if we look over here, we actually have another isosceles triangle. That's because it has side BD and sides BC congruent, so these angles are going to be congruent. So I'm going to subtract 64 from 180, and then I'm going to divide it by 2, and that makes each of those answers 58 degrees, and we get choice 3. Number 6, this seems to be another question that they're really asking frequently on the Regents exams, where you are given the equation of a circle, but it's not in center radius form, and we have to use the process of completing the square to get it that way. So I notice a couple of things. I have variables on the left, I have variables on the right. I want all of the variables on the left-hand side. So I'm going to subtract 8x over, I'm going to put it next to the other x term. I'm going to add 6y over, put it next to the other y term. And here's what we're looking at. X squared minus 8x plus y squared plus 6y equals 39. This looks much better. We have all variables on the left, anything without a variable on the right, and all the x's should be together than all the y's. After the 2 x terms, I'm going to put like a little blank space in here. I'm going to do the same thing after the 2 y terms, and you've learned in algebra that whatever you do to one side of the equation, you have to do to the other to keep it balanced. So I'm going to put 2 of those blank spaces on the right. All right, the key is looking at this number in front of the x, the coefficient, this coefficient, and for each of those values, you're going to have it and square it. And anytime you do this, you will get a positive every time. No matter what number you multiply by itself, you get a positive. So -8, have it, I get -4. -4 squared is plus 16. And let's fill that in on both sides. Now look at the coefficient of 6. Have it, I get 3. Square it, I get 9. And I'm going to add 9 to the other side. Now these 3 terms are factorable. These 3 terms are factorable. And over on the right, I'm just going to add these values and I get 64. Well, if I look at this, it says x minus 4 times x minus 4. So basically, x minus 4 is being multiplied by itself, and that means it's being squared. Same with the y plus 3, and then we have the 64. All right, so now we have it in center radius form. The center can be found by taking the opposite of the numbers in the parentheses. So that would be 4, -3 then. The radius is the square root of the number at the end. So radical 64 or 8. So we want center 4, -3, radius 8, and that is choice 4. Right, number 7, in the diagram below of parallelogram ABCD, we have line segment AFGB. CF is bisecting angle DCB. So I'm going to just put in here that angle DCB is split into 2 congruent parts. And DG bisects angle ADC. So I'm going to mark that off as congruent angles. And then we know CF and DG intersect at E. All right, we know that angle B is 75. Let's label that. And then we're looking for the measure of angle EFA. So again, any of these angle problems, think about it almost like a puzzle. You might not be able to find the answer right away, but if you continuously fill in missing pieces in the problem, you'll be able to get there. The other key is sometimes people get frustrated by these questions. If you look at the answer choices, I can pretty confidently rule out 3 and 4 because this angle definitely looks like it is an obtuse angle. So keep that in mind. And I know it says on the Regents that diagrams are not necessarily drawn to scale, but they really always do make the pictures accurate, so, or close to accurate, right? So if this looks obtuse, it generally is going to be an obtuse angle measurement. But we're going to actually show it's choice 1 or 2, but just as a hint, we could eliminate 3 and 4 here. Okay, so if I have a parallelogram, I'm just going to draw one off to the side here. And this is 75. This has to be 105. This has to be 75. This has to be 105. Because in a parallelogram, the opposite angles are congruent. The consecutive angles are supplementary. So let's take that information and fill it in. So I know angle A is 105. Up by angle D, instead of writing 75, I'm going to take 75 and have it, since we can see that it was bisected. And up by angle C, I'm going to take 105 and have it. And I get 52.5 for each of those angle measurements. Okay, so again, let's try and find the missing angles and then split them up accordingly because of the angle bisectors. All right, now let's see what other angle relationships we can find. I see that I have a triangle here. Every triangle has an interior angle sum of 180. So I'm going to subtract the 2 angles that I know. And I got that this missing angle in here is 90. And by vertical angles and supplementary angles, all of these are going to be 90 as well. I also see, this is a good one to look for, if you have parallel lines, look for a Z shape. The angles in the corner of the Z are the same, so 52.5. And look, I'm really close to that question mark now. Here, these 2 angles must add up to 180. They're a linear pair. So subtract 180 minus 52.5. I get 127.5, or choice 2. Number 8, what is the equation of a line perpendicular to the line whose equation is 2y plus 3x equals 1? So this question is always on the Regents too, except sometimes they make it parallel. Perpendicular lines have slopes that are negative reciprocals. So that means the fraction is flipped upside down and the sign is changed. So let's figure out what the slope of 2y plus 3x equals 1 is. I can't figure it out yet because it's not in y equals form. So let's move the 3x over. Let's divide by 2. And I get y equals negative 3 over 2x plus 1 over 2. So the slope of this line is negative 3 over 2, but I need the negative reciprocal, so that would be positive 2 over 3. Let's look for the answer choice that has a slope of positive 2 over 3, and that is choice 1. Number 9, triangles ABC and RST are graphed on the set of axes below. What sequence of rigid motions will prove triangle ABC is congruent to triangle RST? Okay, just a tip for these questions. Even though it says sequence, sometimes people think that might imply that there are multiple transformations happening, and they might then eliminate choices 1 and 2. So it can mean just one, one transformation. Okay, that's possible for sequence. So don't eliminate 1 and 2 here. In fact, choice 2 is going to be our answer. I can look at this picture and it looks like a 180-degree rotation. It looks like I've been flipped upside down, or the triangle's been flipped upside down. But normally the origin is our center of rotation. But if I zoom in on this here, the center is not an equal distance from the two triangles. The point that is an equal distance is 1, 0. So if you look, that you could go diagonally, you can count using like a little triangle, using slope, but that's 2 diagonal boxes. This is 2 diagonal boxes. So this is going to be choice 2, a rotation of 180 degrees centered at 1, 0. Number 10, if a line represented by y equals negative 1/4 x minus 2 is dilated by a scale factor of 4 centered at the origin, which statement about the image is true? Okay, so anytime you're dilating a linear equation, you want to decide, is the center on that line or is it not on that line? So for the line y equals negative 1/4 x minus 2, we want to determine, does it go through the origin? You have a few ways you could do this. You could plug 0, 0, which are the coordinates of the origin, into the equation. Or you have a calculator. There's no reason you can't use a calculator. So you could type the equation into the calculator. And graph it. You can see it's not going through the origin. Or we could just think about this, right? It has a y-intercept of negative 2. So how could it possibly go through 0? So the center of dilation is off the line or not on the line, and it's the origin. And anytime that happens, here's what you do. You keep the slope, and you multiply the y-intercept by the scale factor. So the y-intercept was negative 2. The scale factor is 4. If I multiply those, I get negative 8. And that is going to give me choice 1. The slope is negative 1/4. The y-intercept is negative 8. 11. Square math has a side length of 7 inches. What three-dimensional object will be formed by continuously rotating square math around side AT? So let's draw this out so we can have a little bit of a visual. So square math, when you're labeling and you're drawing your own shape, you want the letters to go in a circular motion. Okay, so don't jump across the shape to put A, go in a circle. And it has a side length of 7. Since it's a square, all sides are 7, right? If we rotate this around side AT, here's what that's going to look like. I'll do it in a different color. Imagine it flipped over, but it's rotating. We have something circular going on here. All rotations go in a circular manner. And you can see this now looks like a cylinder. So choice 1 and 3, definitely out. And now we just have to think about, is it choice 2 or 4? Is the diameter 7 inches or is the radius 7 inches? So if I go back to that picture, here's the radius. That's that 7. Look at the tick marks we have before. So the radius is 7 inches, and that's going to make this choice 4. All right, for the last one in this video, circle O has a radius of 9 and it's drawn below. Central angle AOC is 120. What is the area of the shaded sector? Notice the little trick here. They are not giving us the central angle in the shaded sector. We have to do an extra step and find it. So subtract from 360. So the central angle is 240. And we're going to use the formula central angle, I'm abbreviating CA for central angle, over 360 pi r squared. So that's 240 over 360 pi. The radius is 9 squared. So if you're typing this into the calculator, by the way, don't put pi in the calculator. I can tell this problem wants it in terms of pi because I can see it in the answer choices. So I'm going to type in everything besides the pi symbol. You see I get 54. Now add the pi back in, and we get choice 4, 54 pi. Okay, you can head to the next video in this playlist to see the answers to 13 through 24.